Hello and welcome to another video of Wise Interactive Learning. So in the previous video, we had seen question number 4 of 6.5 exercise, which is this particular exercise, and in this particular video we are going to see question number 5, where we need to find what are the absolute maximum and absolute minimum values. So what does absolute maximum and minimum values tell us? Well, it only tells us that in any interval which is given to us, if it is in a closed bracket, then you need to find out the absolute maxima and minima using first derivative and second derivative test for those two particular turning points, as well as these 2 points, which is A and B. So if we start with this procedure and if we see what are the different absolute values, so we'll take the first question of the question number 5, which says f of x is equals to x cube, and it also gives a comma and it gives another function which is equals to x. So first we will only go through x cube, and when x belongs to minus 2 to 2. So now if we take the first derivative test, what it will be? So it will be f dash of x is equals to 3x square. So if we want to equate 3x square, or rather f dash of x equals to 0, it will be equal to 3x square equals to 0, which also means x equals to 0. So at x equals to 0, this is a turning point, or rather if we have to plug in x equals to 0, there is a turning point in that particular equation. So here we have one specific value. Now if we want to insert f dash of x into the second derivative test, so f double dash of x equals to 6x. So since if we take 6x and we want to plug in what is the value of x equals to 0 over here, then we don't find any exact circumstance where we can exactly tell you whether if the number is negative or positive. So it means that the second derivative test over here fails, right? So we only have a one turning point over here and we have to find out what are the values, but we are given another two values which are minus 2 and 2. So we have to plug in now all the values and we need to see what are the maximum and minimum values. So f of minus 2, what it will be? F of minus 2 will be minus 2 whole cubed, which is going to be negative of 8. Then we have minus 2. If we come to the right side, we have 0. So f of 0, it is going to be x cube, which is going to be 0 cube, which is also 0. And then it is going to be f of 2. So it is going to be 2 cube, which is going to be 8. So here clearly from f of minus 2 and f of 2, we can see that the absolute minimum value is minus 8 and absolute maximum value is plus 8. So you can say that the absolute minimum and maximum value for this particular function is going to be minus 8 and plus 8. So since this question f of x is equals to x, which is the question number 2 in question number 1, we are not going to solve since it is very easy. So we will move on to the second question. Second question says f of x equals to sin x plus cos of x when x belongs to, or rather the angle belongs to 0 to pi radians, right? So we will check this question, how can we tackle this question. So the second question is f of x is equals to sin x plus cos x when x belongs to 0 to pi radians. Now in this particular question, we can say f dash of x is going to be cos of x minus sin of x, and f double dash of x is going to be minus sin of x minus cos of x, or in other words it is going to be minus of sin of x plus cos of x. So we have taken minus 1 out common here. So if you want to progress from step number 1, which is first derivative test, we can say that cos of x equals to sin of x. If you want to equate it to 0, then what is going to be the condition? The condition is going to be cos of x is equals to sin of x. And if we take 0 to pi, what are the such values where sin and cos are equal? So what is the value of pi? Pi is nothing but 180 degrees, isn't it? So we can clearly see that at particularly sin of x is equals to cos of x, there is only one angle which is 45 degrees, as we know, which is 1 upon root 2. So in terms of radians, it is going to be pi upon 4. So here we can find cos of x equals to sin of x when x belongs to 0 to pi, then we have x equals to pi by 4. So now we want to insert this value inside this function, isn't it? And we need to find out then whether the value is going to be positive or negative. So that particular instance will tell us whether the function has a negative value or a positive value in that particular way. But are we missing any kind of angle where the values of cos x and sin x are same? Well, if you look 45 and another angle, we can say it as 135. So in 135 we can some people may have confusion over here. So sine of 135, which is nothing but sine of pi by 2 plus pi by 4. So this angle is still in between pi 0 and pi, so we need to check these angles also. So sine of pi by 2 plus pi is going to be, so since sine is positive in the second quadrant, it is going to be cos of pi by 4. But what is the value of cos of pi by 2 plus pi by 4? So since it is going to be same cos of 135, it is going to be negative sine of pi by 4. So here you can clearly see that these two values are not equal, and hence only one angle we have, it is going to be 45 degrees. So if we plug in x equals to pi by 4 in this f dash of x, which is second derivative test, we can clearly see that this particular number is going to be negative, since sine of 45 is going to be positive. So when you add two positive numbers, you get 1 upon root 2 plus 1 upon root 2, which is going to be root 2, and negative root 2, since the number is negative, we can clearly say that this is giving us a local maxima. So at x equals to pi by 4, we have a local maxima. So now we have particularly 3 points, which are, first we have 0, then we have pi by 4, and then we have pi. So now we just need to plug in all the values and then we need to check. So f of 0 we need to find out, which is sine of 0 plus cos of 0. Sorry, I have written this as theta. So it is going to be sine of 0 is 0 obviously, and cos of 0 is 1. So this value is 1. Now you have f of pi by 4, which is sine of pi by 4 plus cos of pi by 4, which is going to give you 1 upon root 2 plus 1 upon root 2, which is going to be root 2. Now you have f of pi. So now sine of 180 degrees, sine of pi plus cos of pi. So you need to find out what are the values of sine of pi and what are the cos of pi. So sine of pi, we know that any multiples of 180 degrees for sine, they are going to be 0. And what are cos of pi? So cos of pi is going to be minus 1. So the value of this function is going to be minus 1. So now we need to find out what are the values. So root 2 is nothing but a 1.41. So clearly we can say that we have two values over here. So f of pi, it is minus 1. So you can say that f of pi or minus 1 is the absolute minimum value, absolute minima of this particular function, and f of pi by 4 or the value 1.41 or root 2 is the absolute maximum value of this particular function. So now we are done with the question number 2. Similarly, we are going to see what is the question number 3 and question number 4 for this particular. So what is the question number 3? Question number 3 says that f of x is equals to 4x minus half x square. Question number 3 says f of x is equals to 4x minus half x square, but for this particular we have been given a time in the interval which is minus 2 to 9 by 2. So now we need to take the first derivative test. F dash of x clearly says 4 minus 2 divided by 2, so it becomes nothing. So it is 4 minus x. So if we equate this to 0, then we have x equals to 4. and f double dash of x we have minus 1. So clearly f double dash we are getting a clear value which is negative 1. So clearly we don't have any substitution for x equals to 4 in this particular. So this test over here we clearly don't have any circumstance where we have the input value of x equals to 4 in the double derivative. So this test over here fails. So we only have one instance where x equals to 4 from our equation, but since we have two values minus 2 and 9 by 2 in absolute given values, we can clearly see that we have a point where we need to check the values to find the absolute maxima or absolute minima. So now we have three values, f of minus 2, then we have f of 9 by 2, and then we have f of 4, and clearly we need to again just substitute the values in this particular function which is over here. So 4 times x which is minus 2 minus 1 half x square which is minus 2 whole square. So this is going to be the value. Again we have 4 times x which is 9 by 2 minus 1 half 9 by 2 whole squared. So again this is going to be a value. So just for substitution purpose I am not going to write down all the stuff inside. So if you look at this, this is minus 8, then this is minus 2. So minus 8 minus 2 becomes minus 10. In this particular value we have over here 2 times 4 which is 2 times, so this is 2, this is 1, so this is 38 minus 81 upon 4, so this is going to be 38 times 4 is going to be 152 minus 81, 152 minus 81 is going to be 71 upon 4. So if you take the valuation you will get easily onto this. So this is going to be 16 minus 16 divided by 2 which is 8, so it is going to be 8. So clearly we need to see what are the values. So this is minus 10, so we can say that f of 2 is, or minus 10 is the absolute minima of this particular function since we are there, and this particular value where it is close to 23 I guess, so it is 22.75, 71 divided by 4 is nothing but 22.75. So here you can clearly see that the highest value or the maximum value which is f of 9 upon 2 or 22.75 is the absolute maxima for this particular function. Now we'll take the fourth question which states as x minus 1 whole squared plus 3 in the range of minus 3 to 1. So if we take a look at the fourth question, it says f of x is equals to x minus 1 whole squared plus 3 for the interval of minus 3 to 1. Now in this format also we are going to find out what are the first derivative and second derivative test in order to find if there are any turning points. So in the first derivative test we have f dash of x, clearly we can say 2x minus 1 we have over here. So if you want to equate this to 0, then we have x equals to 1. So we have a point x equals to 1 which can be a specific value if we need to check the turning points. So f double dash of x you can have it as 2. So clearly the second derivative test over here fails and we need to check all the points. So the first point is which we have is x equals to 1, then we have minus 1, minus 3 and then 1. So we'll go in the ascending order. So since these 2 points are same, it's just a redundancy. So x is equals to 1 or minus 3. So we need to check f of minus 3 first and then f of 1 after that. So what is the equation? X minus 1 whole square. So minus 3 minus 1 whole square plus 3. So this is 4 squared plus 3 which is going to be 19, and then again x minus 1 whole square. So we have 1 minus 1 whole square plus 3 which is going to be 3. So clearly you can see minus 3 gives us the highest value, plus 1 gives us the lowest value, and so we can say that f of 1 and f of 3 minus 3 gives us the absolute minima and absolute maxima respectively for the given function f of x. In this way we have completed the question number 5. So in the next video we'll start with word problems for this particular exercise 6.5, which is starting from question number 6. Thanks for watching and see you in the next one.